Good morning, my dear little children. Today we'll continue our lesson on calculus. We shall look at application of differentiation, gradient at a given point. Gradient at a given point. I'm aware at the basic school, you all learned what is known as gradient. Gradient. Can somebody tell me what gradient is? I hope by this time it is ringing in your head that gradient means slope. The gradient of a line is the measure of the slopeness of the line. And I know you did gradient at the basic school. So the gradient of this line measures how the slopeness of this line. And we all know that the line slopeness is uniform throughout the line. And the slopeness of the line here is the same thing as the one here, the same thing as the one here, throughout the line, the whole length of the line. If we want to get this properly, we can draw a horizontal line like this and use it to take the measurement. The angle here, if we shift the line up, try to measure the angle here again, you get the same value. You shift it up, measure the angle here again, same value. Shift it up, measure the angle here again, the same value. So the gradient of a line is uniform throughout the line. When you find the gradient at this particular point of the line, it is presumed that the rest of the line at any given point here has the same gradient. But same is not with curves. Same is not with curves. Let's take this as a curve. 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 The slopeness of this curve as you trace along the curve is not the same throughout. We can use the horizontal line principle to look at this. If we draw a horizontal line and begin to measure the angle this curve makes here with the angle it makes here, it's not the same. The angle the curve makes here with the angle it makes here, and even over here, see, it's very wide. So it's not the same throughout the curve. It's not the same throughout the curve. So with curves, the gradient at a particular point, let's say the gradient at this particular point will not be the same thing as the gradient here, and neither will be the same thing as the gradient here. So with curves, as you travel along the line at the curve, the gradient changes. And as such, you need to always recalculate the gradient at that particular point. It's not like the curve that when you know the gradient at one point, it is the same throughout the line. With curve, it is not so. So we're going to learn how to find the gradient of curves at a particular point. That is what we are come to learn today. Good. Good. From differentiation, we learn that when a function is given and is differentiated, that function can be called the gradient function, or we can call it the derived function if it's differentiated one's first derivative or the differential equation. These are some of the names that you can give to the results of your differentiation. But I will hammer on the first one, gradient function. Good. It is not because of anything. All of them. If you differentiate a function, the result is the derived function, uh, or you can call it the differential equation. You can also call it the gradient function. Now, it is called the gradient function because when you differentiate the equation or the function that you obtain becomes something like a formula for obtaining the gradient at any particular given point on that curve. That is why it is called the gradient function. That is why it is called the gradient function. Good. So let's pick our first question for the day. First question for the day. Our first question is find the gradient on the curve y is equal to 4x squared minus 5x at the point where x is equal to negative 1. Find the gradient on the curve y is equal to 4x squared minus 5x at the point where x is equal to negative 1. So we are going to find the gradient function first, because as I said earlier on, to be able to obtain the equation, the gradient, you need a formula, something like a formula. So the formula to obtain the gradient at any given point on this curve is the gradient function. So we have to what? Differentiate this function to obtain the gradient function. So, and instead of writing gradient function, I can write dy over dx is the same thing as the gradient function, writing the words the gradient function. So anytime you see dy over dx, I'm saying this because some might have joined the class for the first time. So let's proceed. So our dy over dx, we're going to differentiate this function. You multiply this by the power here by the coefficient here. Then reduce the power by 1. You want to differentiate this function. That is how it is done. You multiply the power there by 1 and reduce the coefficient by 1. So this becomes 4 multiplied by 2, then x to the power 2 minus 1, minus 5 multiplied by 1 because the power here is 1, then x to the power 1 minus 1. Then this becomes 8x. I'm not writing the 1. 2 minus 1 is 1. I'll not write it. It's unnecessary. And then number raised to the power 1 is the same thing. And in indices, it is always omitted. Here I can decide to write poly 5. I'm writing poly 5 because we are left with x to the power 0. And no, x to the power 0 is the same thing as 1. And 1 multiplying the 5 has no value, so I will not write the x. So this is my result of my differentiation. And this becomes the gradient function of this equation. And as I said, it becomes something like a formula for obtaining the gradient at any particular point. So at x is equal to negative 1, and the value of my gradient function or my dy dx will be equal to 8 into negative 1 minus 5. I'm going to have negative 8 taken away 5. My result becomes what? Negative 13. So the gradient on this curve at the point where s is equal to negative 1 is negative 13. Remember, gradient has no unit, so we just write 13. I hope you understand. If you don't understand, you can leave a voice note on the page, or you can write your question on the page. I will come and answer. But it should it should be before 8 o'clock in the morning. After 8 o'clock, I can no longer respond to any questions on this video. So take note. Take note. Now let's look at the second question. The second question is, find the gradient on the curve y is equal to y is equal to 5 minus 2x minus x squared minus 3x squared at a point where x is equal to 0. So as we did earlier on, we need to determine the gradient function of this equation to obtain the gradient function of this equation. So our dy over the x will be equal to, we're going to differentiate this function term by term. So we'll start with the 5. See, with the 5, there's no coefficient variable here. But remember, in our previous question, when we differentiated and wrote x to the power 5x to the power 0, we ignore the x and we only left the 5, because we said x to the power 0 is the same thing as 1, and 1 times 5 has no value. So when a constant term is standing like this and there's no variable attached to it for you to differentiate, it means it can be understood as 5x to the power 0. Then you multiply the 0 with the 5, 0 times 5. Then reduce the x by 1, you get negative 1. In effect, this becomes 0, and 0 times the x make everything 0. I hope you get it. So in simple terms, we say when you differentiate a constant term, it drops. It becomes 0. And that is the reason why it becomes 0. I wanted to take my time to explain why a differentiation of a constant is 0. So this one is 0. Good. So 0 will not write. Then we'll come here. The power here is 1. So we'll multiply that by the 2 here. So we have negative 2. Then it will power decrease by 1, become 0. It means the x is also dropping. Then the coefficient here is 1. So we'll multiply 2 here by 1. We'll get 2. So minus 2. The power is reducing by 1. So it becomes x to the power 1. We will not write that one. Multiply this one by 3. Get negative 9. We do the power by 1. So it becomes x squared. Good. So this is the gradient function, or the formula to obtain the gradient at any given point on the line. And the point we are supposed to obtain the gradient is x is equal to 0. X is equal to 0. So at x is equal to 0, our dy over dx is equal to minus 2 multiplying 0 minus x 9, 0 is the power 2, and everything here drops. Everything here drops because of the 0. And our final answer becomes 2. So the gradient at the point x is equal to 0, and the curve y is equal to 5 minus 2x minus x squared minus 3 squared, the answer is 0. Let's look at the third question. The question 3 states that we're supposed to find the coordinate at a point on a curve y is equal to 2 over x squared, at which its gradient is half. At which gradient is half. As usual, we will obtain the gradient function. Don't let this one look so scary. The y is equal to 2 over x squared can be rewritten as y is equal to 2 x raised to the power negative 2. By applying the laws of indices, when you want the x squared to come up, you negate the power. Now that we understand this as y is equal to 2x raised to the power negative 2, we can now find our gradient function dy dx. The same principle, you multiply this by the power here and reduce the power by 1. So this becomes negative 4x and reduce the power by 1. Negative 2, when you reduce it by 1, becomes negative 3. So that's the gradient function. The gradient is half, but we don't know the value of x for which the gradient is half. So we need to obtain that value. Since dy dx is equal to half, we know that from the question that the gradient is half. It means dy over dx is equal to half. Since dy over dx, that's the gradient, is equal to half, that's the gradient. We can say minus 4x cubed minus 3 is equal to half. Now solving further, we can rewrite this as negative 4 over x raised to the power positive 3. The same principle as we applied earlier on is equal to half. Then we cross multiply. So we have negative 8 negative 8 is equal to x cubed. We find the cube root of both sides. Find the cube root of both sides. The cube root of negative 8 is negative 2. So s is equal to negative 2. The question is demanding for coordinates, but not the value of x, is coordinate. So coordinates, it means our answer should be of the form x comma y. So the x coordinate has been obtained. We need to obtain the y coordinate. How do you think we can obtain the y coordinate? I think your answer is as what I'm coming to tell you. You will just put in the x value into this equation. So to obtain the y coordinate, to be y is equal to 2 on negative 2 squared. Then we are going to get 2 over positive 4. On the square and negative number, the results become positive. Take note, most students have been making mistakes. So simplifying further, this becomes half. So the coordinate at the point where the curve has a gradient of half becomes negative 2 for x, comma, and half for y. Good. So this is the required answer. If you have any question, you can drop a footnote, voice note, or you can type it in the page. I'll look at it. Your question should come before 8 o'clock, or else I'll respond to you after 5 p.m. Take notes. Let's look for at the last question. Then I'll give you some assignments to try your hands tomorrow we shall look at tangents and gradient, equation of tangent and equation of normal to a curve. The fourth question for the day: find the coordinate of the point on the curve y is equal to x minus 1, x plus 1, where the gradient is 2. So, as usual, we are going to obtain the gradient function dy dx. Now, our dy dx can be obtained by using two methods. The first method is just expanding the bracket and we'll differentiate it term by term. The second method is what we call applying what we call the product rule. For the sake of Gabler, Emanuela, I'll take my time to use of this opportunity to explain what we call the product rule. So Gabler, those who can use the product rule or who know the product rule can just skip this even and move on. Forward this and move on. But for the sake of Gabler, Gabler, when you have two functions, a function whereby two expressions like this are multiplied and you want to differentiate them, you can use the product rule. Because this parenthesis is multiplying this parenthesis. That is why we call it the product rule. Product rule. Product just means multiplication. So we are going to apply the product rule to solve this problem. Now, what I want to do is that we will let the first one be called u, and the next one be called v. In that instance, I can write my y is equal to u dot v. The dot here means multiplication, please, where we know my u is equal to x minus 1 and my v is equal to x plus 1. So when you have two functions that are multiplying like this, two different functions, you see this is the x minus 1 can be taken as a unit, as a function on its own, and this one can also be taken as a function on its own, and they are multiplied. The parenthesis means they are multiplied. We can use the product rule to do the differentiation. This question is so simple. We can expand the bracket. Expand the bracket, we get x squared minus 1. Then differentiate term by term. But there are certain instances where expanding the bracket will not be all that easy. It can become laborious. For instance, if assuming here was having a power like 10, this one having a power like 5, expanding here to 10 and expanding here to 5, then multiplying the results will be a little bit laborious. So the product rule, you must learn it so that when you meet such questions, you can apply the product rule to solve them instead of always expanding. Now, what is the formula for the product rule? I'm going to write the formula down and then I will explain. By the product rule, to find the gradient function dy dx, we'll first maintain v, then we'll multiply the differentiation of the function u, which is written as the u over dx. Remember, if I say the u over dx, it means there's a function whereby u is equal to an expression involving x. So you go there and differentiate. Then we add it to the results of multiplying u, the function u, by the differentiation of v, which is also known as the v over the x. Please do not let the du over the x scare you. It is not something different from what the dy over the x that we've been doing. If you have dy over the x, it means you are differentiating a function involving in the form of y is equal to something involving x, etc. Expression involving x. If I write du over the x, it means I have a function or a formula or an equation which has u as a subject and have something blah 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 involving x. Similarly, if I write the v over the x, it implies I have a formula which has v as a subject and has something involving x blah 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 blah, and I want to differentiate. And if we're differentiating all these, whether it's u is equal to something blah blah blah, whether it's v is equal to something blah 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 blah, we are still applying the same principle whereby we multiply the power by the coefficient, the same principle. So let's look at how we are going to do this. Good. Now let's find our du over dx and then the v over dx. Du over dx, same principle. We go to the u, to the power here is 1, multiply here by 1, reduce the power by 1, becomes 0. So 1x to the power 0 is still 1. Differentiation of a constant, it drops. So the u over dx is 1. What of the v over dx? The v over dx is also 1 because the power here is 1. So multiply the coefficient here 1 and the power is reduced by 1, becomes 0. So 1x to the power 0 is still 1 and the constant here vanishes. Then I will just substitute everything into this equation. So the y over dx becomes my v is x plus 1 dot, the dot here means multiplication, dot 1 because the u dx is 1. I add the results to the u, which is x minus 1, dot 1 because the v in the x is also 1. Anything times 1 is the same thing, so my dy over the x can still be x plus 1, x plus 1 plus s minus 1 because this bracket times 1 has no effect. My Hungarian function becomes x plus s becomes 2x and then 1 minus 1 drops. So that's my Hungarian function. On the other way around, I said you could have just expanded this bracket. When you expand the bracket, you're going to get x squared minus 1. So when you differentiate the function, dy dx, the 2 will come and multiply the 1 here, you get 2x. And then this one drop. This approach looks very simple than using the product rule. Yes. In fact, with this simple question, expanding it and differentiating term by term is simple. Meanwhile, I explained the reason why I have to use the product rule to let you understand the product rule. This refers to Gabler Emanuela. To understand the product rule, because there will be certain instances that the expansion may be difficult. Here can be power negative 1, or power negative half. See, in those scenarios, the only method you can use is the product rule. And that is why I have to take my time to explain the product rule to you. So this is the product rule. Allow Emmanuel, you can write it down. As and when the lesson progresses, there are certain principles I'll be teaching you from time to time. So take key note of that. So continuing, our gradient function, as you know, is now 2x. It's now 2x. And you know the gradient is 2. But we know the point where the gradient is 2. So we are going to find the value of the coordinate x. Since the y ds is 2, remember the y ds is the same as the gradient. Since the y ds is equal to 2, and we also know that the y dx is 2x, we can say our 2x is equal to 2. This implies our s is equal to 1. We are looking for coordinates, so we want to find the x coordinate, the y coordinate, by substituting the value into this formula, s minus 1, x plus 1. So x minus 1, that's 1 minus 1, then s plus 1. So that's 1 plus 1. And everything becomes 0. Remember, 1 minus 1 is 0, and 0 times anything is 0, so everything drops. So our coordinates is 1 comma 0. I hope you've gotten this. So this is what that we discussed today. Have a nice day. If you have any question, drop your comments or your questions under the video. I can respond before 8, as I said, but not after 8. After 8 will be after 5 p.m. because I will be busy within the day. Thank you very much for making time with me. I'll be pasting an assignment under the link of this video. You try the assignment. Under the assignment, I will provide only the answers, but not a step. You're not supposed to submit this assignment to me. Try your hands on them. The answers have already been provided. You are only to solve to obtain those answers. If you have questions concerning the assignment, you can private message me. I'll give you more light on the assignment. Thank you very much once again for making time for me.